Okay, so welcome to the second installment of graphing quadratics. We're going to be graphing and starting to describe them. Same way that we graphed linear and described them, now you're going to be able to find the domain and range and all that stuff of quadratics. Okay, so as a reminder, we are working with standard form. You're going to have to find the vertex, which is basically finding your axis of symmetry, the negative b over 2a formula that we have. Okay, you're going to use your calculator to help you get your table of values. Make sure you're using parentheses for negatives, right? When we substitute in negatives, we need to use parentheses. We're going to graph it, and then we're going to start describing it. All right, so we'll start with the basic y equals x squared. Very, very easy graph to do. A is 1, B is 0 because it's not there, C is also 0 because it's not there. This is possible to have these things missing as long as you have an A value. So we're going to do x is equal to negative b divided by 2a. B is 0, so 0 divided by 2 times 1 is still 0. So that is going to be the middle of my function. All right, and then 2 numbers less and 2 numbers more. All right, and we're going to substitute these in. Again, we're going to use parentheses when we deal with negatives. So this is going to be negative 2 squared, which is 4. Negative 1 squared, which is 1. 0 squared, which is 0. 1 squared, which is 1. And 2 squared, which is 4. We have that nice symmetry going on. Okay, so your axis of symmetry is the x value of your vertex, and we write it as x equals 0. That's why that formula is x equals negative b over 2a. You do x equals the number. The vertex was 0, 0. Let's go ahead and graph it, and then we'll talk about the domain and range. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. All right, so nice curve going through the points. Try not to make it pointy. I did make it a little bit pointy on that one. Okay, so the domain, if you've done all the linear, the domain are all of your x values, right? And we start talking about how we start at negative infinity on the left and go to positive infinity on the right. If your graph is pointing both left and right, that means your domain is going to be all real numbers from negative to positive infinity, just like it was with linear, because these do keep going. That's what the arrows mean. It keeps going forever and ever. And even though it's really, really steep, it is still going out to the left and out to the right. So our domain is from negative infinity to positive infinity. Now, the range, this is where it gets different from linear. With linear, it was pointing up and down, okay? These quadratics are either going to point up or down, okay? So you can't have both sides as far as all the positive infinity and all the negative infinity. It doesn't work because you're going to stop somewhere. So in this case, our y values stop at 0. That's the lowest it goes, and it's at the vertex. So my range goes from 0, and since it's going up, it's going to positive infinity. All right, let's try a couple more where it's not sitting at 0, just so you can see how it changes. Okay, so we have x squared plus 2x plus 5. Again, I'm just going to write it out. A is 1, B is 2, C is 5, because I only want the coefficients. Okay, so my vertex and axis of symmetry is based on negative b divided by 2a. So change the sign of b. That's going to be negative 2 divided by 2 times 1. So negative 2 divided by 2 is negative 1, and that is now the middle of my function, so it's the middle of my table, just like on the first day of graphing these. Okay, 2 numbers less, 2 numbers more, going the other way, going to left and right on a number line. And we're going to substitute these in, and we're going to remember to use parentheses. So for the negative 3, what you should have is negative 3 squared plus 2 times negative 3 plus 5. And that's exactly how you should type it into the calculator. Or if you're going to do it yourself, just make sure you're doing exponents first and then multiplying and then the adding and subtracting. So this should be 9 plus negative 6, which is 3, plus 5, which is 8. Okay, so that should be 8. And again, if we've done this right, then the number on the other side should also be positive 8. All right, so negative 2 squared plus 2 times negative 2 plus 5. That's 4 plus negative 4, which is 0, plus 5, which is 5. And again, the 0 matching point should also be 5. And then negative 1 squared plus 2 times negative 1 plus 5. That should be 1 plus negative 2, which is negative 1, plus 5, which is 4. And then 0, I know is going to come out with 5 because, again, all my x's are going to cancel. That's my y-intercept, so that's going to be 5. And then if I substitute in 1, again, it should match my other points. That's 1 plus 2 plus 5, which is 8. Okay, so we know that the axis of symmetry is where the vertex is, so that's x equals negative 1. The vertex is negative 1, 4, that middle point. All right, so the domain, I could actually do the domain now before we graph it because I know it's going to go all the way to the left and all the way to the right. That's what these do. But let's go ahead and graph it and see what it looks like. So negative 3, 8, a bit further down. Negative 2, 5, negative 1, 4, 0, 5, and 1, 8. All right, so a nice curve. Let's see if I can make it a little bit more curved this time. There we go. That's a nice curve. Okay, so again, it's pointing to the left, it's pointing to the right, which means my domain is going to be from negative to positive infinity because my x's, right, those are my x values. You're going to be able to put in anything I want. I can put in positives, negatives, I can put in 0, I can put in fractions, decimals, and I will still get an answer. So let's check the range. Look at your vertex and look at the way your graph is pointing. The vertex, the y value is 4, that's right here, and the graph is going up from there. So that means my range starts at 4, that's the lowest it can go, and then goes up to positive infinity on the y. All right, so that vertex is a very important point. Again, not only is it the middle of our graph, it's where it gives our axis of symmetry, it's how we get our range. We'll be doing several other things with it. So it's a very important point. All right, let's try a negative one. Okay, so in this case, A is negative 1, B is negative 8, and C is negative 17. All right, so let's start with the vertex. Okay, so the vertex being negative B, so change the sign of B, divided by 2 times A. So that's going to be positive 8 divided by 2 times negative 1. So that's going to be 8 divided by negative 2 is negative 4. Okay, so negative 4 is the middle of my function. And 2 numbers that are less and 2 numbers that are more. Okay, so we have our axis of symmetry already. It's x equals negative 4. That's the vertex. So let's start substituting these in. Again, make sure you're using your parentheses since we're substituting in all these negatives. Now, be careful. There's another negative here. So when you substitute this in, if you need to, put a negative 1 there. Okay, because that's really what that negative is. So what you have is basically negative 1 times negative 6 squared minus 8 times negative 6 minus 17. Okay, so that is going to be negative 36 plus 48 minus 17. That's positive 12 minus 17. That's negative 5. Hopefully I got that right. All right, and let's try negative 5. Negative 1 times negative 5 squared minus 8 times negative 5 minus 17. That's going to be negative 25 plus 40 minus 17. So that should be negative 2. All right, so let's try negative 4. Negative 4 squared minus 8 times negative 4 minus 17. And that's negative 16 plus 32 minus 17. So that's positive 16 minus 17 is negative 1. So we now have our vertex at negative 4, negative 1. And again, I'm going to trust that we did our symmetry right. This number should be negative 2, and this one should be negative 5. So let's go ahead and graph those. Negative 6, 2, 3, 4, 5, 6. Negative 5 is right there. Okay, 1, 2, 3, 4. Negative 5, negative 2. Negative 4, negative 1. And back down the other way, negative 3, negative 2. And then negative 2, negative 5. Okay, so again, nice curve. Try not to make it look pointed. Okay, so there's our graph. So again, if it's pointing to the left and to the right for our x values, again, the domain is going to be from negative infinity to positive infinity. You're going to get every number you possibly want, including 0, decimals, and fractions. All right, so now let's take a look at the range. The y value for the range is negative 1. And the graph is going down from there. So it's going towards the negative infinity for the y. So that means my range is from negative infinity, because we always put the smallest number first, to negative 1. So the graph will basically get every single possible number that is negative 1 or less. Okay, so let's try a couple more, make sure we're good. All right, so A is negative 2, B is 4, C is 1. All right, so our vertex axis of symmetry first. All right, so change the sign of B. So that's going to be negative 4 divided by 2 times negative 2. And negative 4 divided by negative 4 is just 1. Middle of my function, middle of my table. So less and more. And no, this order does not matter as long as you're doing the next stair steps. All right, so we know our axis of symmetry is x equals 1. Let's go ahead, substitute them in. Let's see what we got. Same thing with the negative on the last one. It's negative 2, parentheses, negative 1 squared, plus 4 times negative 1 plus 1. That's replacing both of these x values with negative 1. All right, so that's going to be negative 2 minus 4 is negative 6, plus 1 is negative 5. All right, keep substituting these in. Negative 2 times 0 squared plus 4 times 0 plus 1 should be 1. And then negative 2 times 1 squared plus 4 times 1 plus 1 is going to be negative 2 plus 4 is 2 plus 1 is 3. So now we have our vertex. And again, I'm going to assume that we did this symmetrically like we're supposed to. That's going to be 1, and that's going to be negative 5. All right, so let's go ahead and graph it. Negative 1, negative 5. Got that. Okay, 0, 1. 1, 3. 2, 1. And 3, negative 5. All right, so nice curve. There we go. Okay, and so just like the last one, this one is pointing down. So the domain is not going to change. That's negative infinity to positive because it is pointing to the left and to the right. All right, so the range. 3 is going to be my highest value because it is pointing down towards the negative infinity. So that's going to be, parentheses, negative infinity to 3. Since again, we put the smallest number first, and negative infinity is a lot smaller than positive 3. All right, one last one. We'll make sure you're good. All right, so A is 1, B is negative 6, C is 13. Again, formula. negative b divided by 2 times a. So that's going to be positive 6 divided by 2 times 1. And that's going to be 3. Middle of my function, middle of my table. 2 lower, 2 more. All right, and we have our axis of symmetry as x equals 3. So let's go ahead and substitute these values in. 1 squared minus 6 times 1 plus 13. 1, that's negative 5. That should be 8. Okay, and then 2 squared minus 6 times 2 plus 13. That's 4 minus 12. That's negative 8 plus 13 is 5. All right, and then 3 squared minus 6 times 3 plus 13. That's 9 minus 18. That's negative 9 plus 13 is 4. And then the other two should be matching 5 and 8. So our vertex is 3, 4. I'm going to go ahead and fill in the domain just because I know it has not changed. All right, let's go ahead and graph it so we can see if it's pointed up or down this time so we can figure out our range. So 1, 8, 2, 5, 3, 4, 4, 5, and 5, 8. Where's that point? There we go, 5, 8. And again, a nice curve through our points, not pointed if we can help it. Okay, so the graph is pointing up. That means it's pointing towards positive infinity for the y. So the vertex is now going to be my lowest point. So my range is from 4 to infinity. And that is it as far as day 2 on graphing quadratics and describing. The next lesson is going to have even more things that you can describe about this, just like you did on linear.